Well, thank you very much for joining us. Welcome to the Scicloj community. As you can guess, we are a community that discusses all things data science and how we're going to use Clojure to build tools and applications that make data science more accessible to everybody. And this community all started from a thread in Clojureverse. And since then, there's been lots of really great events so far. We've had TechML by Chris Nuremberg. We've had a really involved discussion about deep learning with Karen Meyer. Discussing all things around MXNet. We've had Nextjournal by Martin Cavalar, and that's an amazing data science platform for creating journals and using a range of different languages to build data science solutions. And last time we had libpython, CLJ, and Panthera projects, which really helps Clojure developers make use of all the kind of amazing and prolific Python projects that are out there. So this week we're going to look at visualizing data science, which is an important step to help explain what all the data science actually means, especially to people who are not data scientists like myself. And so we've got a number of those talks coming up over the next few months. And today, Christopher, do you prefer Christopher or Chris?
Either way, I'm pretty flexible. In writing, I usually use Christopher, but usually people call me Chris, so either way.
Okay, so this is Chris. So he's going to talk about Oz, the great and powerful scientific document and data visualizer. So that should be, I really like the title, the subtitle of that project.
Yeah, thanks.
It's a pretty cool project as well. I mean, I've seen some of the videos as well. So it's a really interesting like project to work with. And as well as that, as well being the major contributor, then Chris is also a founder of the and chief data scientist of Polis, which is an AI-powered survey tool for open-ended feedback and participatory democracy, which also sounds quite interesting as well. Yeah, and you can find Chris on GitHub at Metasaurus.
Yep, as well as most other places on the internet.
Yes.
So, fortunately, it's a handle that's not very frequently used, so I get the share everywhere.
Yeah, I think you just need to be careful how you say it. So yeah.
Yeah, the spelling's a little tricky. Yeah.
Yeah. So while we go through this, feel free to ask questions either by voice or by chat, and please share your webcam if you're online. I know Eric has. That's great. If anybody else is feeling brave and wants to share their cam, it's nice for Chris to be able to see who's talking to as well. And if you're not talking, please mute your microphone as well, especially if there's a torrential rainstorm outside, like there is in my house. Oh my, that's pretty scary. And with that, I'm going to hand over to Christopher. So Chris, off you go. Thank you very much.
Awesome. Thanks so much for that introduction, John. Really appreciate it. Yeah, I'm going to share my screen here. Is everyone got that? Cool, great. Yeah, so I'm excited to be talking with you today about Oz. Oz is, as has already been mentioned, a Clojure toolkit for data visualizations, scientific documents, and data science workflows. And we'll get into a little bit more how all these sort of pieces fit together. But one of the challenges, I think, in explaining what Oz really is that in some ways it is kind of a Swiss Army knife and has evolved beyond its initial somewhat humble beginnings of having focus really more corely on the usage of data visualization as a data science tool. So one of my goals for today is to really give you a sense for all of these different features and how they fit together. And I think the best way to do that is going to be to do some live coding, so that you can really just see kind of in the flesh what all these components are and how they fit together. So one of the things I really love about this format is that, it's a great way for folks to, turn on their mics and ask questions if there's something they're curious about, finding out more about. So please do that. I highly encourage. It sounds like someone's making a little noise there. Can someone turn off their microphone? Yeah. Okay, that's better. So please do, if you have any questions or just want to interject something, please feel free to pipe in. So just at a high level, kind of give you a sense of the different points that we're going to be touching on here. the features that that Oz has, which hopefully I may not get to all of these today, but just so that you're all kind of aware, the sort of core feature, what really started Oz, is a REPL API for data visualizations. And this sort of lets you, if you're working at the Clojure REPL and have some data that you want to get a better sense of, you can use Oz to create a data visualization that pops up in a browser, and you can start to interact with the data that way, and you know, really kind of go back and forth between the REPL and the browser. And so if you've used R's, ggplot, or you know, plotting utilities from a number of other languages, so it's a really similar kind of flow in that way. But we also offer a reagent API. So once you've kind of done your initial exploration and are ready to take something and make it, build on it, make it shareable, make it more interactive, that reagent API lets you kind of take things in that direction. We also offer the ability to compile to HTML. So not only individual data visualizations, but documents, which might contain data visualizations and math typesetting, et cetera. This, you know, as I mentioned before in one of the other slides, is based on, you know, Markdown and Hiccup. So either which way, whatever your sort of preferred flavor of you know, creating pages is for some context, you can be embedding these data visualizations within them. Now, this actually includes static site generation, which is really cool. I hope this is one of the things I hope to be able to show off today. And in some ways, which is where this sort of Swiss Army knife model starts to break down, right? Because the static site generation as a feature could totally live almost entirely on its own, right? And so that may actually end up happening someday. But for now, it actually works really well as this kind of complete package. The next thing that hopefully we'll get to is publishing and sharing functionality. So, you know, once you've created a visualization or even a document, which might contain visualizations, there's a publish function, which lets you push that online and paste the URL for folks you're working with so that they can take a look at what you're looking at. And then the next thing is notebook integration. So I'm not actually a big notebook user, even though it was kind of how I got started in computer programming way back in the day with Mathematica. Yeah, lots of folks really like working with notebooks. And again, as part of my goal here in Oz being a sort of really high leverage and flexible Swiss Army knife, you know, I wanted it to be something that, you know, no matter how you might be using Clojure and wanting to do data visualization, you know, I want to try to offer something for folks in that intersection there. And so for both the Clojupyter and iClojure kernels, you know, we're kind of fortunate here that we have actually two different kernels to use Clojure in the Jupyter Notebook environment. We've got plugins for both of those, which allow you to embed data visualizations. And finally, live code reloading, something that, again, sort of breaks out of this initial mold of specifically data visualizations and kind of more into like data science workflow toolkit space. So again, going to be going over all these in more detail here. So hopefully we'll get a better sense for how all these kind of fit together and hopefully see that they do fit together. But before I go on too much further, I just want to take a little bit of time to cover Vega-Lite and Vega. Because really the data visualization, while it's kind of grown beyond the initial scope that Oz had, data visualization really is still a really core and key component to the library. So so with that in mind, we should talk about the engine that's powering these data visualizations. So Vega-Lite and Vega are declarative, data-driven data visualization languages. And when I say data-driven, I actually mean that these data visualizations are JSON data structures. And they are based on the grammar of graphics, which if you've used R's ggplot2, you're very familiar with this. The GG and ggplot comes from grammar of graphics. D3 has been inspired by some of these ideas. I think Plotly, a number of other different frameworks have learned from the grammar of graphics, and it's been really influential in the space. But one of the things that Vega and Vega-Lite bring to the table that's sort of novel is this idea of a grammar of interactivity. And it's, this is one of the things that unfortunately I won't be able to even, I mean, there's too many other things to cover today. I won't be able to even scratch the surface of the kind of interactivity that's possible with just Vega and Vega-Lite, even without getting into reagent or anything like that. But hopefully I have time to just see just a little bit. And one of the things that makes the interactivity so powerful is that there's a functional data flow model built into these Vega and Vega-Lite specifications. So within them, you might be, a data visualization might let you select a collection of data points. And then that data selection could be used as input data, which then informs the rest of the visualization. But that only really works and makes sense if you have this kind of data flow model where you can take that data in and then kind of compute something from it, which then sort of flows into some property or aspect of the visualization. So this ends up being kind of really valuable and key to that interactive side of things really working. One thing I want to say here, and I actually didn't put IDL up here, but Vega and Vega-Lite are built by the Interactive Data Lab at University of Washington. And to me, this is one of really the strengths of it as well, is that this isn't just someone's random project. Like this is a whole this is a whole lab at a really great university that's doing really incredible work. And between D3 and Tableau, a lot of big things that have come out of the sort of data visualization community have come from folks who've worked in the IDL. So it's a really great lab. They're doing really great work, and you can kind of rest assured that this kind of underlying framework here, Vega and Vega-Lite, is being ushered forward by some really thoughtful, smart folks. So if you're interested in getting a better sense of Vega-Lite and really kind of how it works, what you can do with it, all the sort of bells and whistles, I'd really highly recommend this YouTube video titled Vega-Lite, A Grammar of Interactive Graphics. And you should be able to search on YouTube for that and find it. Does a really great job of giving you just, running the mill of everything that Vega and specifically that Vega-Lite can do. Now, if you're interested in the kind of underlying philosophical connections between Vega, Vega-Lite, and Clojure, there actually are some really kind of interesting deep threads that connect the two. And so if you're interested in that, I've got another talk that I did at Amperity it was a little while ago now. It was almost a year ago, I think. Well, no, not quite. Anyway, whatever, some months ago. And that's titled Vega, Vega-Lite, and Clojure. So you should be able to search on YouTube for that as well. So yeah, again, if you're interested in learning more about Vega and Vega-Lite in particular, I'd recommend checking out those two resources. But for now, I kind of want to move on because we've got a lot of other stuff to cover. So the one thing which I do want to drill home, though, is that, part of what makes Vega and Vega-Lite so magical to me is just the fact that they are data specifications. It seems, it may seem either sort of incidental or maybe almost encumbering, but it really is one of the things that enables a ton of power with it. I could not have built the toolkit that I built and made it possible for folks in the Clojure community to use all this work. It was not for the fact that these visualizations are just data specifications. And what this means is that they can be created from any language with a natural interpretation of JSON. So whether you're a Clojurist or whether you're a Pythonist or Pythonista or JavaScript or R, whatever, everyone can be creating these specifications, sending them over the wire to a web browser and rendering them and sharing them between each other. And that enables a lot of synergy, really, where it doesn't even matter kind of what your framework or toolkit is. When you sort of build around these data specifications, you get a ton of leverage because you can take that anywhere you want to go. And so I think that's one of the real strengths of this model. Yeah, so I keep talking about Vega-Lite and Vega, so that to kind of tease these two apart and explain why there are two things that I'm talking about instead of one. Vega is the sort of original embodiment of this notion of data-driven declarative data visualizations, and it's extremely powerful and customizable, configurable. But unfortunately, due to that kind of sheer power, there's a lot of stuff that kind of requires a lot of boilerplate and makes it a little bit challenging to use as a day-to-day data science tool. However, it's great as a compile to target because of its flexibility. And again, because of the fact that it's just data, you know, whatever sort of language or framework you're in, you can be building these specifications dynamically. This is one of the other things that makes this paradigm really powerful, right? And effectively using Vega as a compile to target. So if you're familiar with Gorilla REPL, which is a really cool Clojure notebook environment, its data visualization functionality is based on Vega. And this was actually my first sort of encounter with Vega was through Gorilla REPL. And unfortunately at the time, you know, when I kind of dug into Vega, it didn't seem right for me for like a day-to-day data visualization tool, but it you know, it sort of kindled the interest. Vega-Lite is in some ways sort of an unfortunate name because it can kind of give the impression that it's sort of watered down or not, you know, not as powerful, and that's not really the right way to think about it. It's actually extremely powerful, but sort of geared in different ways than Vega is. Whereas Vega's power is geared towards really maximizing the kind of set of things that you might possibly be able to do. Vega-Lite pulls back a little bit on that flexibility, but really gives you a ton of power as far as being able to really quickly do things that really give you a lot of leverage over your data. Effectively, by kind of cutting out a lot of the boilerplate and, you know, giving these kind of higher power pieces of functionality, it's able to be a really powerful and productive day-to-day data visualization tool. But at the end of the day, one of the things that makes it great is that Vega-Lite just compiles to Vega, right? So if you're doing your day-to-day data visualization work and you come up with a visualization that you really like and want to build on, maybe turn into part of an application, but need to kind of customize beyond what Vega-Lite is able to accomplish, you can compile that to Vega and then just go to town with all of the, you know, bells and whistles that Vega has to offer. So together, this combination is just really powerful. These things kind of play on each other really nicely. So now you've been talking about this kind of abstractly. It helps to just look at an example and really just see like what is it that we're actually talking about here. So this is a, this is a really simple Vega-Lite example where you know, the first thing that we're doing here is specifying our data. And in this case, we're using a URL, which is convenient if you have a lot of data or, you know, want to refer to data on the web somewhere. But note that you can also specify values here and just pass in a list or vector or whatever you want to call it of data dictionaries or objects, which is useful if you're at the REPL and, you know, actually have some data that you just want to literally pass in. The next thing that we do here is we specify the mark. So I said that Vega and Vega-Lite are these sort of declarative grammar of graphics mappings. And the idea there behind the grammar of graphics is that we should be able to describe data visualizations as mappings from properties of our data to aesthetics of a data visualization. And specifically here, what we're doing is we're saying that we want to take these data points and we want to mark them as, I shouldn't have used the word point there. We want to take these pieces of data, these datums, or entities, I guess is a little bit more appropriate, and we want to represent them as points in a data visualization. The next piece here is the encoding, which tells us how we're actually doing that mapping. Like what properties of the data are we mapping to which aesthetics of these marks that we're creating. So in this case, we're going to be mapping the field horsepower to the X aesthetic in of these data points, and we're mapping miles per gallon to the Y aesthetic of these data marks. And then, well, this is not necessary. It's kind of helpful to see that, you know, there's some other kind of properties here that you can specify. So if we wanted to color by another variable like origin, then we can specify that as well here. So what we get then is this nice little visualization, and this is just a static image here, but we get this nice little visualization, which is exactly what we expected, right? It's miles per gallon versus horsepower, and we're coloring by origin here, and it gives us a key and a legend and everything. So the equivalent, just for reference, the equivalent Vega that would have required to create this as sort of a bare bones minimal thing would have been 2 or 3 times as long. There would have been a bunch of kind of configuration. It wouldn't have come with axes. It wouldn't have come with the legend. It would have been very bare bones, which is sometimes what you want when you're building something up as an application. But again, it's just an example of the kind of value add that Vega-Lite provides. Now, as far as how you actually use this from Clojure with Oz, it's really very straightforward. So all that we do is, if you're using line again, you can add Metasaurus Oz, this is the most recent version here, to your project CLJ under dependencies. And then once you have a REPL running, or just in whatever code you might be using, you can require oz.core as Oz, and then run the Oz view function, which in this case, we're passing just a single Vega-Lite specification. And data URL, right? So we're passing in the data URL. This is effectively the exact same specification we saw before, except that we're representing it as Eden, which is Clojure data. If you're not familiar with Clojure, kind of coming in new here, it's sort of like the JSON of the Clojure world, and we just translate this into JSON and send it over the, well, let's see, actually, we're getting to whether I guess we send it over the wire, and then we translate it to JSON, and then in the browser pass it on to Vega for visualization. So I'm going to kind of stop here. The next thing I'm going to be doing is kind of just opening up REPL and getting into some live coding. But I want to stop for just a second and see if anyone has any questions.
Yeah, Christopher?
Yeah.
So are you actually familiar with ggplot? Mm-hmm. Like, have you? Yeah. So is using Vega kind of like building up a ggplot object from scratch with groups and going really into the grid system? Is that what you mean?
Yeah, I haven't used the grid system as much. So I'm not sure exactly how fully I can answer the question, but it's very similar to, in my mind, it's very similar. And so depending on what language or toolkit you're using to create your Vega-Lite specifications, it can actually be very, very similar to ggplot. So in particular, while I tend to kind of emphasize just build a data spec by hand effectively and then pass that around sort of side of things, the Vega-Lite library itself actually does have some functions which lets you kind of build on an ongoing specification, kind of as you would see with ggplot. There's also in Python, there's the altair library, which is really rather clever. I mean, I'm not an object-oriented fan, but it's got some really cool meta programming where it actually ingests the JSON schema specifications for the what Vega and Vega-Lite should look like. Well, specifically Vega-Lite, because it doesn't do Vega, but it ingests those and actually dynamically builds a object-oriented API based on that. And so the net result is something very, very similar to ggplot, where you create this plot instance and you actually pass in a data frame for the data. At least by default, there's other ways you can pass the data in, but and then you call these methods on it kind of in sequence to add this aesthetic or that aesthetic, this mapping, that layer, etc. So yeah, it's very similar. And again, it's based on the grammar of graphics. So some of the names are a little bit different, but all of the concepts map very, very kind of cleanly. So yeah, I mean, if you're coming into this with experience with ggplot, you'll feel right at home. And honestly, I mean, if you had told me that I'd be saying this like however many years ago, I'd have told you were crazy, because I was a huge ggplot2 fan. I mean, when I was back at Fred Hutch Cancer Research Center and you know, doing data visualizations day in, day out, I used ggplot2 all the time. And in no other language had I really found something that I liked as much, or that was as powerful. But you know, pretty quickly after getting into Vega-Lite, I realized I was blown away by just all the things that it could do that that actually ggplot2 couldn't. So the interactivity, I mean, I guess Shiny kind of gets into some of that stuff now, but really it's it really stands out. I pretty quickly became 100% sold that, you know, I'm not going back, basically. I found my environment. So
cool.
Yeah, thanks for that question. Anyone else? Okay, cool. Well, without further ado then, please stop me if you do think of something that you want to ask. But without further ado, I'm going to open up a REPL here, or a terminal, whatever. And hopefully that's big enough for everyone to see. You know, let me know if it's not. But I won't get too much into my setup here, but I like to use... I'm kind of old-fashioned as far as my coding environment goes. I just like to use tmux, which is a terminal multiplexer, so I can have multiple terminal sessions open at once. And what I'm going to be doing here is generating a new Clojure project with the line tool, which, if you haven't used Clojure before, this is just the there are a couple of other tools out there that you can use, but it's sort of the longest running Clojure build tool, which kind of lets you create new projects and run projects, etc. And so I'm going to use this to create a new project. We'll just call it Oz demo. And it's going to take a second to fire up and create that. But once we have, then we can cd in here. And again, I mentioned that the only thing you really need to do to set up Oz in your project is to add a dependency on the project. So what we do here is add Metasaurus Oz, and the most recent version is 1.6.0 alpha 3. So just, you know, if you're following this at home in the future, just check to see online on the webpage what the most recent version is. And
Chris,
yes?
Is it possible to increase the font size a little bit just to make it easier?
I can, yeah. Yeah, I do have a big screen here, so...
yeah, so do I.
Yeah. Hopefully that's better.
A little bit more would be great if you could do it. Like a couple more sizes. Yeah, that looks a bit better.
Okay, great.
Yeah, there you go.
Yeah, cool. So next thing, now that I've saved this file, I can, in my other terminal pane here, I can go ahead and run line REPL. So that's going to go and fetch this dependency on Metasaurus Oz. You'll see in a second here, it'll print that out. Oh, right, it's already required. Yeah, so we already have it, so it didn't print it out. But anyway, yeah, so now that we've got that loaded, I'm going to open up one of the files here that was created by Oz, by Linegan when we initialized this project. And, you know, just created a dummy function here, so we're just going to go ahead and nuke that. Now the next thing that I'm going to do is I'm going to add a dependent, that is to say, I'm going to require the sort of core namespace here of the library, which is Oz core. And in Clojure, we can give that an alias. So I'm going to require that as Oz for ease of use here. Now, one of the things, right, just a second. I forgot to change directories in here. Okay, there we go. Yeah, so when I ran line REPL, I wasn't in the same directory yet, so it wasn't connecting. But now that I'm in there, that should work. So just one thing real quick while that's loading up. It's if you've used Python or Ruby or even Node, JavaScript, right? You're probably familiar with the idea of a REPL, this sort of interactive session where you can be typing in code and evaluating it, and Clojure is no stranger to the REPL. And in fact, Clojurists are sort of a little bit rabid about their usage of the REPL as a productivity tool. Now, while it's totally fine to just run all these examples directly in the REPL here, right? I could come in here and require oz.core as oz, and it's going to take a second to actually load up the dependencies. But once that happens, I could go in here and be directly typing in all these coding examples in this REPL, right? But if you're someone who's been coding for a while, you probably have a development environment that you really like to use. In my case, I use Vim, and you know, I'm a fish out of water without it. But really, you can use whatever environment you want. The key thing, though, is that if you're going to be doing a lot of Clojure development, you probably want an editor that can connect to a REPL and directly evaluate code from the editor. So I'm going to show you how that kind of works here. For me, I can highlight some code, hit a button, and it evaluates it. Just as another kind of simple example here, if I wanted to print line hello, I can highlight that and execute it, and it prints out hello down below. I know I'm probably going over some very basic things that anyone who's used Clojure might be familiar with, but just kind of want to put that out there for folks who might be kind of coming in a little bit new to it. Now that we've required that namespace, what we can do here is call Oz view, and we're just going to run this same example that we had before. And yes, I'm just pulling up my notes here. Okay, so first we're going to specify the data, and again, this is going to be a URL, https vega.github.io editor editor data cars.json. And the next thing we're going to do, again, is specify the mark. We're going to be using point here. And next being coding, where X is going to map to field, horsepower, and Y is going to map to field miles per gallon. And then color is going to map to the origin field. So now that I've written this up, I can actually just execute the whole file. And what we should see here is that a browser window pops open. It'll print this message at first, waiting for first spec to load, sort of technical reasons for that. But once it does, we see this great little data visualization here. And I'm going to make that a little bit smaller. But and so already kind of you get a sense that there's some kind of built-in interactivity here with the Vega tooltip functionality, where, you know, as I hover over data points, it'll display a little tooltip with kind of some of the basic information that we're visualizing here. And this can totally be customized, so you can actually, you have a lot of control over what sort of information you can display there. But pretty cool, right? Like that was really quick. You know, we had some data, we ran a specification, and now we've got a data visualization. And we can iterate on this very quickly. So we might go in here and you know, want to do this as a line plot instead. And now once we evaluate that, voila, right? We get a line plot. And just one thing to point out here is that Vega-Lite is just one of the things that makes it special is that it's just really smart about kind of doing the right thing, like knowing what you meant to do and not having to be kind of told to do it, right? We didn't tell it to break up these lines based on origin. It knew to do that based on the fact that, well, if I'm coloring by origin, I can't have like one line for all the data, so I need to break it up by that attribute. And so just one of the things that Vega-Lite's kind of doing for you that you really don't even have to think about, but that really makes it a great framework to use. Yeah, just to kind of riff on things here a little bit and get a sense of some other things that you might want to do. Instead of color, or maybe in addition to color, you might actually want to say facet, or see. Yeah, so we can do a row facet here. So I need to evaluate that, which breaks up the data into different rows depending on what the origin is. We could also, we could also do this as column, and there you go. Or if we really wanted, we could even, map this to shape of the data points. And maybe we'll just do both here. Again, one of the things that one of the things that I remember, yeah, so right, now the data points actually have different shapes. And so, right, you probably would only be doing one or the other here most of the time, but sometimes it's actually nice to use multiple aesthetics to really kind of drive home the point of what, where the differences are between some data, right? Yeah, I'm gonna scale this back a little bit and cut these out, because I want to show some other kind of features of things that you can do. So let's see here. Yeah, so another thing I want to show you, just to get a sense for, you know, how this usage is really, the kind of things that you can do can really get into non-trivial territory. I might want to display both a line and which, yeah, right. So one of the things I might want to do here is display a line which bins the data. And we'll see what that looks like in a second here. And then, right, so what we're doing is we're binning along the x-axis, so that instead of displaying all of these data points, we're sort of averaging over these bins. And the way that we do that is specify bin true for the x-axis, and then aggregate mean for the y-axis here. And so, oops, wait. I don't know how that got there. So now when we take a look at this, so now we see this nice smooth path, whereas we had this jagged path before, right? So what's really cool about this is that we can actually combine these two different approaches, right? So where we see all the data, but then also have sort of a nice distribution as a sort of binned line plot. Let's do that one more. Okay, so to do that, we use the layer functionality, which lets us combine multiple mappings effectively as layers. This is one of the kind of core ideas behind the grammar of graphics, this idea that you can layer multiple visualizations on top of each other to kind of add context and information. And so for this one, I'm not going to do any of the binning or anything. I'm going to be representing this data as individual points. Take out the aggregate here. And now what I should see, I'm going to do one more thing here, which is I'm going to map the opacity here to just a static value of, say, 0.3. And what we should see now, yeah, so now what we get, and one more thing here I'm going to do to make this a little bit bigger, easier to see. I'm going to do width, say 800, and height, let's say 600. Okay, and evaluate that. And yeah, so now we have something much easier to look at here. But you'll see by taking these data points as individual pieces of data and, you know, making them a little more opaque, and then layering on top of that these sort of binned lines, we get a sense not only for the distribution of the actual data as data points, but also kind of a summary of that, where, you know, summary statistics are kind of lies in a way, right? But they're sort of useful lies, because they give us information that we might be missing if we're really just looking at all the data by itself. But when you combine the two, you can kind of get the best of both worlds, right? So this is just an example of how, you know, some of these features here that Vega-Lite provides us really enable you to do a lot of stuff at once. And while in this case I'm just using the same data set for each of these layers, it's totally possible to use different data sets for each layer. So, you know, if for whatever reason you had different data that you wanted to feed in and visualize in different ways, you could layer those on top of each other using this layer specification here. So I'm going to take a quick pause there. Does everyone have any questions about what we've seen so far? I'll drink some coffee while you think of something. Got to juice up here.
Yeah, that's really cool. I guess you can have as many layers as you want to, and probably you'll make a mess before you run out of like memory. Anyway,
yes.
So
yes. In short. Yeah, cool. So if there's no other questions, I'm going to kind of move on to the next thing here. So one of the things that I did.
There was one question. Is like any idea how much data you can throw at Oz?
Yeah, that's a good question. We have hit some. I think we've resolved most of these issues now. There were early on some. I don't even know exactly what it was. I think. God, the details are escaping me now. Early on, we had some problems with larger data sets getting in, and where things would take sort of an exorbitant amount of time. I think we've dealt with most of that now. I forget what the kind of core bottleneck is, but you should be fine at least up to, say, thousands of data points. If you're kind of in the, say, hundreds of thousands, it could take a little while for that to get in and render. There are... yeah, I mean, some of that may end up coming down to things in Oz that could be optimized. Because I know, using some of these, using the Vega-Lite libraries sort of directly, you can fit quite a bit of data in. And there's even a WebGL renderer that lets you render quite a bit of data, which is really cool. So yeah. Sorry, I'm not giving a very kind of direct answer there. I think sometimes it can also depend on how much you're rendering at once, because it's actually like the rendering performance that I think ends up being the bottleneck in some cases. So sorry, I'm not giving you a super direct answer there, but you're definitely fine in, say, like the tens of thousands territory. Once you start getting to the hundreds of thousands, it can take a little bit of time, but is still usable if you're a little patient. So does that answer?
Yeah, I think so. That was Adam asking that. So, and Dan was asking, is scrubbing selecting enabled by default?
Scrubbing selecting. Can you clarify?
I'm not sure. Well, I can't, but maybe Dan can in the question in the chat.
Yeah, I don't have that open, actually.
I'm sure. Just selecting enabled by default. Does that make any more sense?
Oh, yeah, it's not enabled by default. I'm forgetting what I think you, let's see if I can remember this off the top of my head. I think you
just selecting data points.
Yeah, we can look at that real quick. I've actually got an example of that in here somewhere. Let's see. Vega-Lite, I mean, just to answer your question directly, it's not, but it's very simple to add the selection. Of course, the real trick is, like, what do you do with the selection? And actually, I've got some examples later on in the slideshow. So if you don't mind waiting, hopefully we'll have time to get to that. I'll try to leave some time to look at some of the interactive examples at the end of the slides.
Yeah, I'm sure that's fine. Yeah.
Yeah, cool. Anything else?
I think that's it. I think they're just comments.
Okay. Yeah, great. Okay, get back over here. All right. Yeah, cool. So I'll leave that out for now. One thing that I'll mention real quick is just that I, just like with most coding, I don't actually remember a lot of the stuff off the top of my head. I mean, some of it I do that I use all the time, but other bits, the Vega documentation online is really great. Usually a Google search will get you to something that you want. Also, both Vega and Vega-Lite sites have really great examples sections. So if you go there, you can just kind of scroll through and really quickly visually get a sense of all the different kinds of visualizations that you can create with these frameworks, and usually find something in there that's close to what you need, and then kind of adapt as you will, and combine with other examples, etc. And so hopefully we'll have some time at the end here. I can actually just do that. We can kind of scroll through the examples page, and you can get a rough sense of some of the things that might be possible. So, but yeah, if there's no other questions, I'll kind of keep moving here. So one of the things early on, which I realized would be really nice, and actually, yeah, I mean that kind of came up as a need for me, was that I was wanting to work with both Vega for certain visualizations that I couldn't use Vega-Lite for, but also be kind of combining those in the context of, well, that is, say, combining them with other, say, Vega-Lite visualizations that might be based on the same data, for instance. But also, putting in tables of summary statistics, or other kind of stuff that Vega and Vega-Lite don't really do as well. I mean, you can actually put tables of data in here, but it's not really its strong suit. And so what I realized is that it would be really sort of simple to build on this model and sort of almost extend it with the notion of hiccup. as a language for combining individual visualizations together with other kind of HTML content. So just as a simple example of this, you know, we might create a div here, and then you know, oops, not sure how that happened. Maybe add a title, and what we should see is oh, that's all right. Excuse me. Here we go. Okay. Yeah, there we go. Right. So in the context of this hiccup, I can nest this Vega-Lite specification under a Vega-Lite key, or I guess I should say tag, and it'll render that together with the rest of the hiccup content. So just real quick, because again, I'm trying not to assume that people are coming into here with a ton of Clojure experience. So this hiccup notation is a really simple data notation for expressing HTML or XML content. It's I mean, for me, it's just easier to write out. I mean, if nothing else, right? Yeah, it's also kind of nice because it's just a very simple data model. You can take this stuff, you can dynamically construct it. And when you kind of blur your eyes a little bit and get used to it, it actually looks really similar to XML or to HTML. Yeah, so I prefer using this whenever I can over literally writing HTML. But yeah, I don't know. Maybe we could add another little paragraph in here, some more stuff, whatever. You know, that pops up there. So, you know, so I could be doing lists or tables or, you know, styling and anything that I'd want to do with, maybe just to see a sense of the styles. Actually, that's a good example. So if I wanted to say style this in a particular way, I can add this dictionary here as the second attribute or second entry in this, this vector, which might map, say, color to blue. And, you know, now when I go in here, that's blue. Or I can make it italic, or, you know, right? I could do whatever, right? You've got the full power of HTML here, just in this sort of nice data format. So yeah, I mean, this is one of the things that I think really makes Oz powerful, and which again was sort of the entry point to it kind of evolving beyond its initial humble beginnings as a data visualization framework to more of kind of a complete scientific document framework, right? If you're familiar with Hiccup, you can go in here and now start creating documents where, you know, maybe I've got a code namespace here where I'm doing a bunch of data processing, and then at the very end, I'm spitting out some document which summarizes all that data as data visualizations, as prose, kind of explaining what's going on, etc. Right? So really kind of useful stuff here. Any questions before I go on? Okay, so I'm realizing we're already 50 minutes in here, and I was assuming we were only going to be doing an hour, so I'm going to try to keep moving here kind of quickly. The next thing that I would like to show you is the live code reloading functionality. So what I've been doing here, again, you know, being able to type all this stuff into a text editor and then evaluate it from that text editor is a really powerful way to do things. But there are certain instances I found myself in where I have a bunch of data processing going on alongside the visualization. And in cases such as that, it's sort of challenging to keep track of which stuff needs to get rerun. If I change something up above, you know, if I have a bunch of code that I need to highlight, like, I mean, let's say that, you know, I've got a bunch of, I've got a bunch of code.
Alexa, stop timer. Alexa, set 5-minute timer.
So if I've got a bunch,
starting now.
Cool, thank you. So if I've got a bunch of other stuff that I'm doing in preparation for getting to this data visualization, you know, and I change something up here, having to go up and re-highlight all this stuff and sort of reevaluate it can be kind of frustrating. But one of the things that Oz provides, which gets around this, and specifically gets around one of cases in which this is really valuable is when you have kind of heavy data processing components of your workflow. So if you're going and running some machine learning pipeline, or you know, downloading a bunch of data from the internet, whatever it might be that's taking up much time, you don't want to have to rerun that stuff every time. You know, when I'm moving faster, it's because I'm just reevaluating the whole file. But having to highlight a specific chunk of code and evaluate it ends up taking more time. So one of the ways that you can kind of get around this is using the Oz live reload functionality, which lets me go in here and just specify that I want to load this Oz demo core namespace, and oh, let's see what happened there. Did I not? No, I did. I'm not sure where that's happening, but hopefully that's fine. Anyway, you'll notice that if I go in here and I run something like println hello and save this file, oh shoot, is it not? Something's not working. Oh geez, what's going on there? File, that's odd. I just used this and it did work. Am I missing something here? Oh man, that's unfortunate. Okay, well, yeah, I realize we're kind of running out of time here. So I'm actually just going to, yeah, shoot, that's unfortunate. I'm actually going to skip to one of the other sort of pieces of functionality here that I'd really like to get to, which is the static site generation. So I'll try to do this really quickly. But one of the things you can do here, and really which was the next kind of aha moment for the library, was I realized that, you know, given that this library has functionality for spitting out HTML content based on the hiccup that you're processing, it occurred to me that, oh, wouldn't it be nice if you could also load markdown data and embed visualizations within your markdown. But not only that, but also, you know, process entire directories of markdown data with this kind of content and spit out a static site. And this was something that I kind of dug into and ended up kind of, again, a lot of these pieces that I've been talking about here have kind of evolved organically and naturally, one step after the next. So the function here, which lets us do this, is ozbuild. And what we do here is we specify a vector of build specifications. So we're going to say from site source. And I'm going to actually go ahead and make sure that directory is there first. So site source. We'll be putting some stuff in there in just a second. And we're going to be building to build. And it infers build if we don't specify it. So there's a default for that, but you do have to specify from. Now, the fact that there's a vector of these means that you can kind of customize different directories of input data might get processed differently, which can be kind of useful. So let's go ahead and run this here. And now we're going to open a file at site source, say hello.md. And so now we're going to say hello world, some content, and now we should see oh, right, it's already used. Shoot. Okay, here, so I'm actually going to restart this. This is the joys of live coding, right? Yeah, and so actually I didn't need to restart that. I could have just specified a different port here in ozbuild. But yeah, just gonna make this a little easier on myself. And okay, yeah, okay, great. So now it has it's run that and is sort of ready for me to go in. And now when I come in here and add some more content, we should see that in this, it's still, oh boy, lots of stuff not going right here today. Had I not? Did I? Oh, you know what's the problem? I have another. That's the problem. Sorry, I have another. Process open that's using that REPL port. Let me go ahead and shut that off.
Yeah, we've got plenty of time, so don't worry about that.
Yeah. Okay. Great. Make sure that all those are dead. Okay. Let's try this again. All right. Okay, and we can actually just, let's try, yeah, so we're gonna do, oops, I think it's just port. Let's say 999. And yeah, there we go. Okay, sorry about the sorry about the wait there. Right, so there we go. So now we've got this content up here. And just to kind of further drive home the point here, I'm going to actually kind of separate this off and pull it off to the side, so you can see these things kind of running together. Because this is how I tend to use this. Is I'll have my content open on one side of my screen, and then be visualizing what I'm working on the other. Some cool work, you know, writing a great blog post. You know, as soon as I'm saving this file, everything's being reflected in this live view that I've got running here. But moreover, and one of the things that's kind of neat about this is that if I go in and I add another file to my input, you know, site source directory, like say about.md, then as soon as I save that, it's going to switch to this other page. And this, I've found this really nice to work with, because if you're kind of working on a static site, say a blog or a personal website, whatever, and you're moving content around from one page to the other and adjusting things, being able to kind of really quickly switch context from one page to the other without having to think about going and clicking around to find the right place to see what you're actually building, what you're looking at, is really nice. And the fact that, you know, not only is this live building static HTML as we're doing all of this, but it's giving us a live view of exactly what we're working on, so we don't have to like go and reload. Just a really nice set of features, and I haven't seen anything like this out there in the Clojure community as far as static site generation features go. So you know, it's even if you're not doing data visualizations or data science work, just the fact that you can use this static site generation for personal websites, for blogs, whatever, in and of itself, I think is a really valuable thing. I've really enjoyed working with it. So yeah, let's see what, try to be thoughtful here about what I cover. I'm tempted here to give this one more go on the live code reloading. So I would like to show you that if I can. I'm actually going to pop this back open again. So I'm going to comment this out and plop this back in. And I'm going to try this live reload one more time. Hopefully we can get that. Yeah, I don't know why this is not working. I haven't had this problem before. Bootstrap. Huh. Yeah, I have no idea what's going on there. I'll have to debug that. Yeah, sorry for that. That's unfortunate that I'm not going to be able to show that off. But you know, I'll give just a brief explanation of what should be happening here, and hopefully, you know, later on in some line notes or whatever, we can kind of clear up whatever the issue was. What should be happening is that if I'm going through here and effectively like using this code file as kind of like a live notebook, what happens is whenever I change some chunk of code, this live code reloading is only going to reload all of the code that that has effectively changed, right? So starting from the first form that you made substantial changes to, everything from there on down is going to get reevaluated. And so what this means is that you just don't have to worry as much about like which things need to get rerun, which don't. I found myself in the past doing odd things where if I have some really expensive or computationally expensive steps that I'm doing in some sort of some workflow, I'll sometimes put them in def once so that I'm not rerunning them. But then it gets to be really problematic when I do need to rerun them because something upstream changed. And so then I'm going through and changing def once to def, and then you just get into this kind of mess of having to worry about state and which things to be run and which things have been need to be run and which don't. And this very kind of simple model of just rerunning from the first change in the file when you save it really kind of just removes all of this headache. And I don't use this for normal day-to-day Clojure coding at all. You could potentially, I guess. I find it's usually easier just to be, in control of which forms I'm loading or reloading. But for doing this kind of data science workflow where you're just kind of exploring data, mucking around with it, I've found that it's a really nice toolkit. So yeah, I'm sorry that this isn't working the way I'd expected, but yeah, hopefully we can figure that out and let you know what the problem was there.
Yeah, somebody else was having the same problem when they just tried it as well. So you're not alone.
Yeah, I mean, I literally just used this last night and it worked. So I don't know what's happening here, but yeah.
The joys of live dem.
Yes. Okay, so there's one more thing that I want to show you here, which is if I wanted to share this data visualization with someone, what I can do is call Oz publish. And so when I evaluate this, you'll see that it prints out this sort of long URL here. And I'm going to highlight that and enter. Okay. And now we can go into the, if the font size was a little smaller here, that would have been one line. I could have copied it a little more easily, but in any case, I can go over here now and pop this in and, oh, sorry, that's the wrong URL. I know why that didn't do it. Here, what I'm actually just going to do is I'm going to do that, and then I'm going to rerun this so that it's all in one line, just show you that it's, at least in this particular REPL, if it's all in one line, I can just copy it like that, and we can go in here and pop this in. Yeah, there we go. And now what this is doing is it's pasting this data or posting this data to a GitHub gist. And the Vega online editor has this cool functionality that lets you load a Vega or Vega-Lite specification from a GitHub gist. And so you'd have to set up some credentials and stuff to use this functionality. But what's really cool is that, from going and creating some visualizations here to then sharing with someone who you're working with, a colleague, it just becomes really easy because you can just, run this function, grab the URL, paste it in Slack or whatever, and someone who you're collaborating with can load this up in the Vega editor and actually go in here and start tweaking it and save it. And I mean, it's really kind of a cool set of functionality. But unfortunately, it doesn't support Hiccup because Hiccup's not something that it knows about. But what I did to sort of facilitate this is I built a site called OzVis.io, which makes it possible to share these Hiccup documents, which might contain data visualizations. So if I go in here now and, I can actually just click open link. I don't know why I didn't do that before. It's going to take a second to load up here. I need to improve the performance of this. There's some things I sort of did a little bit quickly. But right here we go. So it pops up. I can now get this URL, again, just paste that on Slack or wherever, and people can go off and take the document that I produced, which might contain a whole sort of blog post or kind of journal document explaining some analysis, and share that with colleagues really easily. Yeah, so look at my set of things here. Yeah, so I don't think I'm going to have time to either show off the Raysion API or notebook integration. And again, I'm sorry that the live code reloading didn't work. Hopefully I'll figure that out and get back to people about what the issue was there. But kind of switching back over here to the rest of the content I have prepared. Some of the other things that are worth kind of knowing about in the Vega and Vega-Lite ecosystem are Voyager, which is a Tableau-like browser tool based on Vega-Lite. And I'll try to be really quick with this. It's a really cool tool. So you open it up, it loads up with some dummy data, actually the same cars data set that we've been playing with here. And right away, without even doing anything, it's presenting some sort of single variable statistics and visualizations, which, we might come in here and say like, okay, this is actually kind of cool. I like this one. I'm going to focus on this. And when I do that, it pops up at the top and sort of fills out whatever sort of configuration we have in that particular plot here in this encoding section. Now, from there, we can go in and do things like go in and add, say, year for a color. I don't know if this is going to work out well. Yeah, it didn't work out quite as well as I'd have. Let's maybe move that one back and maybe do, let's delete that. Yeah, here's a better example, right? So given one visualization, it will suggest new visualizations you might want to look at. So without even having to know which attribute you might want to say color by, you might look at this and say, oh yeah, when I color by cylinders, actually that's really helpful. So I'm going to go ahead and select that one. So really quickly, without doing any coding, you're able to start creating data visualizations in a really sort of powerful way. And what's great about all of this is that when you go in here, you can click Vega-Lite copy or Vega copy and actually copy out the Vega or the Vega-Lite or the compiled Vega, and then paste that into a code file, or again share it with the editor or whatever, right? And so whereas with Tableau, you're kind of locked into the Tableau framework. With Voyager, you have a lot of the same functionality, but at the end of the day, what you get, again, is just this chunk of data that you can share, you can pass around between processes, et cetera, right? So really, this is just an amazing tool, which I highly recommend if you're using this whole toolkit and have any chance of working with folks who are non-technical and wouldn't want to be coding up stuff themselves. This is just a really powerful piece to the puzzle here. There's a bunch of examples here. I'll maybe just do one since I know we're already kind of running over on time. And I'll try to specifically get one that shows us some interactivity. So this is a cross filter example where we've, I'll show you, I'll start actually, oh, here we go. Start by showing you how and let me make this a little bit bigger for folks. I'll start by showing you where in the spec we're adding this, this select functionality. So that's in here, one of the layers that we have is selection. And so it's a brush selection of type interval, and we're brushing the X aesthetic. So when I come in here and then highlight a set of points, what you'll see is it's adding this second layer, which is going to be colored, and which we're doing a transform filter on. And so it's using the brush selection that we created. And so effectively what that means then is when I select data in one of these panes, it's going to do these filters in all the other panes and color that specific set of points that were selected based on those other attributes. So really quickly here, you're able to start interacting with this data and starting to get a sense for how these different variables relate to one another, right? So in this case, if I'm interested in, where do these low time entries pop up in relation to delay and distance? Well, you can start to get a sense for that, right? Maybe I'd want to see where do the high pop up, and I don't see any particular correlation there, but right, you can imagine based on some certain data, you might really be able to start digging in sort of novel and interesting ways to the data, and really, I mean, almost you can almost get the sense of like really kind of digging your fingers in and starting to pull out information that wouldn't be possible with the static visualization. So this is again one of the things that's just really powerful with this framework. So there's a bunch of other examples here. Maybe if someone has questions, we can look at some others. Again, just to go over the highlights here about the functionality that we've kind of covered. There's a REPL API for exploration from the REPL, reagent API for turning that stuff into apps, compiling it into HTML, including static site generation, publishing and sharing features, notebook integration, and live code reloading. All of which hopefully don't make this a Frankenstein monster. I hope that's not the conclusion that we all get from this. To me, we're not here yet. To me, but it's something that that I'm kind of aware of, that as this sort of framework has evolved and grown. I'm cognizant of the fact that it's become more and more challenging to really explain to people what Oz is and like what. Well, simply because it's kind of starting to do so much that you can kind of only point to it as like a Swiss Army knife, but you don't really get a sense for what it is until you kind of dig into each one of these features and see how they relate together. So incidentally, you should find this is actually a knife that supposedly you can buy for $10,000 on Amazon, and the comments on this thing are just ridiculous. So if you're looking for a good laugh, just try to find this Wenger Swiss Army knife on Amazon. So I don't know how that made it past the Amazon censors, but anyway, so that's what I got for now. Thank you for sitting here and listening to me, and I'm happy to take any questions now if anyone has some.
Thanks, Christopher. That was fantastic. Thank you very much for that talk.
Yeah, you're welcome.
Does anybody have any some questions, some comments in the chat? Let's have a look. Oh yes, beautiful. Thank you.
Excellent.
There was a question about using real-time data with Oz, and so one of the suggestions was to be able to kind of create a dashboard for like the Internet of Things. I wondered if you'd done anything in that respect.
Yeah, so Vega and Vega-Lite do have an API which lets you add data to an existing view specification. I haven't exposed that yet through the reagent API. It's something that I've been waiting a little bit to work on because I've been kind of thinking about the way that I want to do it. But I think basically what it's going to be like is a pretty thin wrapper around the kind of core functionality that that Vega-Lite and Vega provide in their view API. So that you can pass in some of these hooks that let you, as you get new data, add that in, or as you have, one of the things I've done in with React and Vega, because I had done some work with other languages using Vega and Vega-Lite, is take the signals which represent data selections and then go and use them in the rest of, say, a React application to figure out which data you're going to put in a table view. And so this ends up being really powerful because then you can have a data visualization like a scatter plot, which you're effectively using as like a navigating window into more detailed view of the data as, again, say like a table or, whatever it might be. Now, I will say that if you're just using Vega or Vega-Lite components, I highly recommend just using the kind of built-in filtering and interactive features to say take two visualizations and sort of connect them, as we saw with the interactive example, the cross filter that I showed you. But in cases where you need to take that data and use it in kind of the greater context of say a React application or some other web application, that ends up being really powerful. So yeah, that is on the roadmap. I just haven't gotten to it yet. The stuff that's been kind of immediately pressing for me with the application has been more at the side of, again, working with documents. The live code reloading, all that kind of stuff is what's been most useful to me. And so that's what I've been spending my time on. My time is kind of limited, so I can't work on everything that I want to add right away. But certainly if folks are interested in helping with that, I would love to have contributions. My whole philosophy with this project has been that I want to make it something that works for everyone, no matter what side of the Swiss Army knife you're interested in using it on. So if someone's interested in taking that feature up, I'd love to help.
Okay, Chris, I have one question.
Yeah, sure.
About static site generation.
Mm-hmm.
Did you manage to generate static images as well from Vega, or not?
Yeah, I haven't done that yet. I've been kind of so there's a couple of routes forward on that. There's actually like I think there's almost like 3. So one is that if you install Vega-Lite or Vega, well, I think you actually just install the Vega node or NPM module to do this. I have to look back to that for sure, but if you install the node module, you'll get a system executable that will can read in Vega or Vega-Lite specifications and spit out a static compiled image, either as SVG or as PNG, or maybe it's JPEG, I'm not sure. But one way to go is to just call out to that shell process. And effectively what that would do is make it so that if you have that installed, then you would get this functionality effectively, right? The other thing that we can do is if you, I believe, and I haven't, I just recently upgraded my Java version, but what I found was that when I tried to use Java's Rhino or Nashorn or whatever they're calling it now, JavaScript engine to load Vega and render, in the JVM process effectively, it wasn't able to with, I think I was using Java 8 at the time. Now, since then, I think since Java 11, that engine now supports the full ECMA 6 standard. So I believe now it should be possible to, if you're on a more recent Java, which feels like people are starting to get updated there. It took me a little longer than I think most. It should be possible to do that. And I actually have a code file tucked away somewhere where I tried to get that working, but wasn't able to. And I just need to go back and kind of revisit that. The third path, which someone actually wrote a library that did this as a fork of Vizard, which actually, I haven't mentioned this yet, but Oz is a fork of Vizard, which was written by Nathan, sorry, not Nathan, not Nathan, what's, Macbeth, something Macbeth, Soren Macbeth, that's his name. Soren Macbeth, yeah.
Soren Macbeth, yeah.
What's that?
Soren Macbeth, yeah.
He wrote Vizard, which I forked as Oz. Someone else had sometime before that forked off as, I forget what the library was called now, but and actually added this functionality where he was sending the visualizations to the front end to like whatever browser you're connected to, having them render there as SVG, and then passing the SVG spec back to the Clojure REPL. So that is another way to go here, which so all 3 of these approaches sort of have their pitfalls, right? It's like if you're trying to do this as a server, on say a server where you're maybe doing a data pipeline, you're processing a bunch of visualizations into static content, into just images or SVG, that doesn't really work as well for you. I mean, you could maybe use Selenium or something like that, but there might be gotchas there as well. With the Java sort of direction, it makes certain assumptions about which Java version you have going. With the node executable, it assumes that you have not only the node module installed, which is the easy part. Actually, what's hard with that is getting, or at least was for me, what I kind of got stumbled on with it when I tried setting it up, was that you have to have, I think it's, so it's the Canvas API. You have to have like Canvas libraries to link to from Node. And for whatever reason, that's been challenging for me on my system. I think on Macs, it tends to be a little easier to set up. So none of these solutions is exactly perfect. And I think ultimately what I may do is kind of try to implement all of them so that, whichever one ends up working for you, it'll just kind of defer to that. Again, this is just one of those things that I have spent a bit of time on, but it's been, for all the reasons that I've described, it's been a little bit of a challenge, and hopefully I'll be able to knock that out soon. But again, just trying to move as fast as I can with the time that I have.
Mm-hmm. Okay, thank you.
Yeah, you're welcome. That's I will say that's definitely a feature that's really high priority for me, because in the past I've done a lot of work where I've had to do that kind of workflow where I have had to compile a lot of static images for whatever reason, and so it's definitely something that I want to support. Yeah, and we'll get into it.
It will be game changer because a lot of Vega and Vega-Lite stuff you can save file from the browser only. So rendering a batch. That's why I started CLJ plot to render a bunch of images offline from the code directly or from the repos directly. Yeah, someone mentioned that there is a wizard fork that supported static export and called Planosphere.
Yeah, that was called I believe it's called Planosphere. Because I had to. You couldn't find it?
I tried to find it.
Okay, well, so recently we went through this at work. I needed to generate many static images, and I wanted to use Oz because that's where I had a better workflow. And what I arrived at, I just ended up using the VG to PNG, like the command line tools, because Planosphere was using an older version of Vega, and when I tried to update things, I got hurt. So happy to contribute to
Planosphere. Okay,
I would love that, and I think the easiest of all these approaches to implement is actually just calling out to the node binaries. That's super straightforward. So maybe we can actually just knock that out this weekend, because that'd be great. If it's easy to install, or if you're already going to install that, then that's that's an easy inroad to getting that functionality, at least in some form early on. So so thank you both for bringing that up. Let's knock it out. I think that'd be great.
Yeah, cool.
Cheers. Yeah, and I also just wanted to say, Tomas, is that right? Yeah, I've looked a little bit at CLJ plot now, and really cool work. I'm excited to see your presentation in a few weeks here and talk more about how all these things kind of fit together.
So it's completely different approach. So
sure, but it's
bottom side and server side most.
Yeah.
Okay, I don't know when. Still don't know when this presentation will going to be, but that's probably on September.
Yeah. Okay. Cool. Great.
So.
Looking forward to it. Yeah. Any other questions?
If I may ask, can you hear me okay?
Yes, yeah.
Hi. So this is Daniel. So I guess what Oz is about, the way I understand it, is about two things. One is connecting to the Vega ecosystem. And the other is a certain workflow that Oz offers, which is about rendering and connecting it to the REPL experience. And so I wonder about the other thing, about what could be done, what more could be done with this concept of Oz, and whether you're interested in making it extensible. I mean, making it possible for users to add components.
Yeah, thank you. That's a great question. That is actually something I've thought about. What I've had in mind for that, and I'm really glad you asked. And first of all, I just want to add, kind of before I carry on with that, if anyone does have things that they want to talk about here about exactly what you're kind of pointing out, which is like directions that things can go, or anything along those lines, I'm all ears. Again, I just really want this to be something that is really as useful for everyone as it possibly can be, without turning into the ridiculous Swiss Army block or whatever. What I've had in mind for that, because I've certainly had ideas for other things that I've wanted to add to this, and the big one which comes to mind, it's actually an issue up for this online, is the ability to add, say, a data table of whatever chunk of data you're looking at, right? Because then you can kind of imagine that's just the kind of thing that I find myself often wanting to do. It's like, yeah, great. It's nice to have a visualization, but sometimes you actually just want a table of maybe not even all the data, maybe just some of the data, but that can be really valuable for presentation and documents for, whatever. And I mean, with Hiccup, you can kind of do some of that, right? I mean, you can just kind of manually construct a table, but it'd be really nice if you had some higher level components where instead of, doing your it's funny, I just realized I never actually showed you how you embed the Vega visualizations in the Markdown. So maybe if we have some time, I'll show you that. But if you have, right, so in our Hiccup, when we want to embed a Vega-Lite visualization, we add the Vega-Lite tag, right? So what I'd imagine is maybe you'd be able to add a table tag and then just kind of pass in your data or refer to it via URL, kind of like you do with Vega-Lite. And that would just kind of go to town and create the table for you, and you wouldn't even have to think about it, right? And maybe there'd be some specification options that would let you, control the order of columns or whether things are sortable, all that kind of stuff, how things might be styled. And it's really easy to see there that you could totally go overboard and make things way too complicated. So I want to try to build something that's just enough and not too much. What that has sort of led me to this idea of is that, the more of these pieces you start building, I don't want to turn it into some kind of like ad hoc, like these are the things that Oz provides and you can't use anything else, right? Because you start to really quickly get the sense that like, oh, well, what if I wanted to kind of extend it in my own way and do something that you don't provide yet and you're not interested in providing because it's too kind of specific to whatever use case you're looking at. And the idea that I've had there is that it would be cool to add sort of I don't know what you'd call it, but like a tag processing or tag extension handler or register or whatever, right? So you call something like Oz register tag handler, and then you specify, Danielle's like crazy, tag renderer. And so now when you go in and you, in here, if it sees any tag that sort of matches something that's been registered, it's going to go through and call whatever function you have specified for that. Now, the challenge in that is that depending on your context, whether you're on the front end in Reagent or whether you're in Clojure and are statically compiling, right? It's like you almost need different handlers for different cases, and that's one of the reasons why I haven't built this yet, because I don't want to build it the wrong way and sort of get myself in trouble. But I think it's really, maybe this isn't the only way that we could do something like what you're talking about. And if you have other thoughts, please do share. But that's what I've kind of had in mind for how you might be able to extend this to your own needs.
Yeah, I guess that is what I had in mind too. If I had to imagine, and I guess anything of this kind will make it possible to just see what kinds of components may be useful, and then we can imagine some kind of order around them, right?
Yeah, right. Yep.
Wonderful.
Yeah, cool. Yeah, and so again, I mean, if anyone's interested in any of this and wants to, kind of chip in, helping even just think through architecturally how these things might fit together, solve some of the conceptual problems, whatever, would love any help folks are willing and able to give.
And what medium would you prefer folks reach out, like through GitHub issues or Clojure and Slack, or?
Yeah, GitHub issues are best. I mean, certainly, if there's room for more of kind of an open-ended discussion, Clojure and Slack is a great place. But I'd say just in general, always start with the issues, because things disappear in Slack. I mean, I know we have the hooks into Zulip, which is great, but I find that just having a record of things in GitHub is kind of my preferred way of keeping track of what's happened and who's kind of thinking about what, et cetera. So yeah, start with a GitHub issue. If things need to kind of fork off into Clojurians or Zulip or wherever, we can have conversations elsewhere. But yeah, GitHub issues are a good way to start.
Thank you.
Yeah, and also, I mean, when I think of something, that I want to add, I usually go and throw up an issue real quick. Not always. There's some things that I haven't added for whatever reason, but it's also just a great place to just check to see if, if you're thinking of something like, hey, I wonder if Oz does or it wants to do or whatever X, Y, or Z, then, just go in and search through the issues. And yeah, absolutely. If there's not something there yet, go ahead and add it. If there's something already there, feel free to chime in. Yeah, cool. Anyone else? Anyone got any jokes?
Not a joke, and I mean, I know Clojure Together is always looking for projects to fund. This might be a good one. I'm not trying to sign anyone up for anything here. Tell them to spend their time. But.
You're not the first person who suggested that. Yeah, and actually, I have submitted, and I think they recently did a survey which kind of gave them their kind of roadmap for some of their priorities over the next several months. And I'm not sure when they'll be doing the next survey, but one of the things I've been interested in is just getting kind of a vote of support for something like this from the community. So if you see the Clojure Together stuff come up and you want to make it known that like, hey, data science is something that that we should be focusing more on as a Clojure community, then please do that, because that's, that'll help out really immensely. I think that, others have talked about this before. There's certainly some holes in the Clojure community as far as, how you use it for data science. Not community so much as ecosystem, I should say. The community has been great, but I think a lot of those are starting to get filled, which is really awesome. I mean, not that long ago, there really weren't a lot of options for visualization in Clojure. I mean, that was one of the pain points I first hit when I got into Clojure. Was like, it was great for doing kind of like the core data munging and data manipulation side of, data science workflow. But, stuff like machine learning and whatever, I mean, you can always fork off to another process for that. But like data visualization for me is just something I do all the time and, really wanted to have as part of my Clojure workflow. And, it's really great that now between Oz and Hanami and CLJ Plot and some other stuff out there too, there's really a bunch of cool stuff happening now, and that's just not a hole that we have anymore. Right. But what I wanted to say is also with, with the lib Python stuff that Chris Nurnberg has been working on, just amazing work, right? In one kind of fell swoop, making the wealth of the Python ecosystem more sort of accessible to us. I really feel like there's just so much potential for Clojure as a language for data science. But there are definitely still some holes. And I think the more that we kind of work to patch those up, and the more that we work to kind of build a sense that, that Clojure is a great, or at least a very, high potential language for working with data science, that will help start bringing more people in. So my hope is that, we can kind of make that message and, sort of convince folks with, in the Clojure Together panel to start funding more data science projects, whether it's Oz or whether it's, libclj, or, libpython or whatever it might be, right? I think that there's a huge amount of value to that. Data science is this kind of rapidly growing field that's considered really high value. And we have a lot of, as a data-driven language, we just have so much potential strength in that ecosystem. So I know I'm preaching to the choir here, so I'll stop talking about that. But yeah, please, please express interest for that if something you want to see.
And you get a chance every 3 months, I think, is the next round of voting and submitting stuff as well. So there's 4 opportunities every year to hopefully get some funding there as well.
Yep.
Anybody else have any other questions?
Colin and Sami here. Hi. Can you see me?
I can't see you, but I can hear you.
Hey, great. Great work. Fantastic work.
Thank you.
Well done. As a ggplot heavy user, a question. It's not actually perhaps so much Oz, but the differences between Vega-Lite and Vega and ggplot. Of course, Vega brings a lot of things that ggplot doesn't do, like the interactivity and stuff like that. But is there anything that you miss from ggplot that you would like to have in Vega?
That's a really good question. I'm really tempted to say no. The one thing that I maybe miss a little bit, but I hesitate to even say, is that at the time, I really liked ggplot's sort of style of, being able to create a visualization specification and sort of add to it. This idea of like creating the base specification and then going and adding some layers to that, or going in and tweaking some things sort of step by step, excuse me, I thought was really nice for iteratively, incrementally building visualizations up. So initially, I kind of missed that when I was getting into Vega-Lite. But more and more, I mean, it's just, and this is probably the kind of thing that really depends on, on the individual, the coder who, and what their kind of preferences and style of working is. For me personally, I really don't mind just writing out this kind of big data spec. And usually when I need to kind of break things down into pieces, it's easy enough for me to, to just kind of do that. It's like, okay, I'm going to define this one piece of the spec here, and now I'm going to go and reuse that here. I mean, that I've found that I end up feeling like I have more leverage over being able to kind of dynamically construct these visualizations if I just leave it as data. That having been said, I do, again, I mean, kind of my mantra here has been and continues to be that I really want to make Oz something that tries as much as possible to cater to everyone, again, without turning into the big, crazy block Swiss Army knife. So I have thought a little bit about what would an API look like that's kind of similar to being able to sort of layer in these pieces. And I really haven't, this is actually one of the things that Hanami does, which is kind of interesting, is that it has some sort of higher level components for constructing visualizations. So, I mean, that's one thing that you might want to kind of look at in that space. It's definitely different from what ggplot does, but very interesting. So I thought a little bit about that kind of side of things, and I just haven't felt really confident that I'd be adding enough value over just the basic specifications. Because to me, when I look at a really simple Vega-Lite specification, it's like got everything I kind of want. I just want to see it as one sort of chunk of data. That's kind of how I personally like to work with things. And again, that's been a little bit of an evolution for me. I think I missed that more at first than I do now. But there's nothing else that I can really think of. I mean, as far as functionality, I think that Vega, not even just in the interactivity, but even in the way that things lay out and faceting and, being able to take two plots and sort of join them together. I know you can do some of that stuff with grid, and I've done that in the past. But I've just found that with Vega, it tends to do the right thing more often than when I'd have to hack certain things together in R sometimes. So for me, it's pretty much only been a positive. There's, aside from that one thing of, the stylistic API kind of decision, which again, just depends on the person. Aside from that, I mean, there's been nothing that I've ever missed. It's had everything that I've wanted. So sorry, that was probably more of a drawn out answer than was warranted, but hopefully that was all helpful.
No, very good. Thank you.
Yeah, you're welcome.
If I may add to the ggplot discussion by Sami, I guess one conceptual difference between ggplot and Vega is that ggplot compiles on the server, on the backend, right? Yeah. On the same runtime where you do your statistical computation. Mm-hmm. And that allows for statistical computation to be part of the compilation.
Yeah.
And And so you may add statistical smoothing of data. Yeah, right? And that may be missing. Or maybe...
So that's a really great point. Yeah, thanks for bringing that up. That is actually one thing that I have missed. Some of the statistical stuff that it provides has been missing in Vega-Lite till actually very recently. So that now there is some stuff that, well, actually, I'm not sure if it's in Vega-Lite yet. I know, I'm forgetting what the status of this is now. I have to look it up, but yeah, I think they just added it. If not, it's in like a release candidate or something like that. But they are now adding some more of that kind of functionality. And so, yeah, it's closing those kind of last few gaps. Yeah, and I think, I mean, if I recall correctly, like Vega has had some of that functionality, which was, I think I mentioned kind of earlier that one of the reasons I got into Hiccup for combining these plots was that I wanted to do something in Vega that I couldn't do in Vega-Lite, but also combine that with some Vega-Lite plots sort of stacked next to each other or whatever. And it was actually exactly that made me do that. It was that I wanted to do some contour plots of some data distributions, and that wasn't something at the time that I could do in Vega-Lite. And it's supposed to be on the roadmap, and I'm not sure if that's one of the things that's gotten in yet, but it's definitely, you know, one of the really nice things about the fact that, again, this is being ushered forward by the IDL, the Interactive Data Lab at University of Washington, is that, they've got a whole team of grad students, and Jeffrey here, who's just great, great researcher, all working on this. And yeah, I mean, they, you know, in my experience watching them work on things, I'll sometimes, I mean, I've had this experience multiple times now, at least like 3 or 4 times now, where there's something that I've tried to do and haven't been able to do it. And I go and I update the version of Vega-Lite or Vega, whatever it is. And like they've added it since then. And in other cases, at least, again, 2 or 3 times that I can think of, there's been a feature that I've wanted and it hasn't been in the latest version. So I've gone online, you know, submitted an issue, and within sometimes a few weeks, they'll have added it and published a new version, and boom, there it is. So, you know, it's really, I can't highlight this enough. Like, it's really one of the strengths of the ecosystem that they do such great work and that they're so responsive, and are doing things as an academic lab, right? I mean, they're thinking carefully, they're writing papers, they're, you know, as closurists, we all sort of respect hammock time and sort of thinking carefully through things before just doing them. And that's one of the things that they kind of bring to the table there, as from coming from an academic perspective. But yeah, I think I said everything I wanted to say there.
Any more questions from the audience?
Yeah.
No,
sorry.
Yeah, go ahead, Daniel.
Yeah, thanks. So maybe we can discuss interactivity for a moment.
Mm-hmm. Yeah, sure.
So both Vega and Vega-Lite, they offer a certain grammar for describing interactions. Mm-hmm. And I wonder how well that may play with the outside world. For example, if you have another component in your page where you wish to react to an event. Have you had? Yeah.
Yeah, I have. And actually, I can show you an example of that. I think, unfortunately, I think the, let me load it up before I share it with you just to make sure. But so let me, viz.org. Here, I'll go ahead and, let's see. Okay, adding, just a minute. Where is it? Sorry, trying to find the right page here. I have way too many windows open right now. Hold on, let me try that again. Share. Oh, here we go. Okay, there we go. All right, so this is, can everyone see that? Yeah, cool. So this is an application. This is actually not in Clojure. This is built with React using I think it's called React Vega plugin, which does very much like what the reagent side of Oz does, but has been a little bit more fleshed out in as far as some of the tapping into signals, et cetera. what we implemented here, I can talk, if you're interested, I can talk a little bit about the kind of domain data here and what we're actually looking at. Unfortunately, we just updated the schema for this, and so we're kind of operating on limited data until we rebuild the data according to the new schema. This doesn't look quite as wonderful as I had hoped to be able to show you, but in short here, what you're able to do is, right, we have a scatter plot here, which, you know, again, if we had all the data in here, there would be a bunch of stuff in here and you'd see some colors and different stuff. But what we can do is, as we highlight data points, we're doing exactly what I kind of described earlier in the talk, where as I highlight data points in the visualization, it's updating what you see down in the table below, right? So as you know, I can even grab this and move it around this window selection here, and the table updates darn near instantly. And so this application then, you know, in here on these sort of detailed points, I can kind of drill in and find out more information about one of these specific data points that we're looking at. And even further, you know, now I can kind of click on one of these data points and see some more information about the history that led to this. If anyone's interested in the domain data, I can explain what's actually going on here. It might help interpret what you're seeing. But the long story short is that, yes, you can absolutely do this. All that we're doing here is we're adding a hook to, I think it's a signal handler is what they call it, right? So should explain a little bit how that kind of relates to things. So again, Vega, Vega-Lite are based on functional reactive programming ideas. And in FRP, we talk about, and sometimes different sort of frameworks, et cetera, can use different language, but one of the kind of common terms is a signal, right? As this idea of, you know, reagent, we tend to call them reactions, or, you know, I think they call them signals in Elm. Yeah, I mean, there's some other terminology floating around there as well. And I'm trying to remember what they are in the React realm, but I think they're called selectors in React. The idea is that in Vega, they do call them signals, and you can tap into a signal, and anytime it changes, you'll get this handler, you know, that you can call and plug into. And for interactivity, every little piece of interactivity you try to add to the application is ultimately ending up manifesting as a signal. And so by attaching one of these signal handlers, you can pipe that data out and use however you want. So in this case, we're taking that data, we're plugging it into the React framework, into Redux, and then, you know, we're doing all the kind of standard React stuff to then like filter and, you know, control of the views based on that. So I'll say that sometimes things can be a little bit tricky where, like, as I go in, I click around here and select different data points. That's kind of a bad example here. Let me try it like that. Okay, so as I go and sort of select different data points, you'll see that it actually updates the visualization as well. So the visualization updates the table, but the table can also update the visualization. You can get into weird sort of loops that way, so you have to be a little bit careful. But you know, as long as things are one way, it's very straightforward. And even when it's both ways, if you're sort of careful about how you're doing things, you can avoid the problems. Yeah, I actually kind of feel like explaining what this is because I think it's so cool. This is, again, I wish all the data was up here because it would be even cooler to look at. But each one of these data points represents a family of B cells. So in immunology, B cells code for antibodies. And antibodies are sort of the front line of defense in the adaptive immune system. So when you knock out a cold, it's your antibodies that are really doing the bulk of the work there. But when you get a new cold, what you're having to do is you're having to take old B cells that coded for the last sort of cold virus that you got, and it's having to evolve them a little bit to adapt to this new cold strain, right? What you get from that are these different related sort of families of B cells. And each one of these points in this visualization actually represents a whole family of B cells. So when we go down below here and we select one of these specific families, what we're looking at here is a phylogenetic tree or evolutionary history of that particular family. And so you can start to drill down and figure out, based on this coloring scheme, it looks like, where it starts to get red here, this is where you started to get a really effective B cell. So you can go in and click on that and find out what was the series of mutations that led to that, that particular B cell that was doing a good job of knocking out whatever sort of virus you're looking at. And this particular data set is based on some HIV research. And, the folks who we built this for are using this to, figure out how to build better vaccines, which is just super cool to have been able to work on. I really feel grateful that, I had this opportunity to work on such a cool project and use some really cool tech along the way. I mean, we, just to kind of paint the technical picture here, when we started this, I'd been using Vega kind of in anger for about like 6 months. So, it was still definitely picking up the ropes. And we had someone join the project who actually did the bulk of the work here. I was kind of mostly overseeing him at the time. And, dealing with some of the finer, some of the thornier issues, et cetera. But he came in not knowing any Vega, actually not having done React before. He'd done Angular, or I think it was Angular and stuff. But really quickly, he was able to get up to speed. And within a period of, I think it was like 2 or 3 months, we were able to build out most of this functionality. And, it's taken, obviously, how projects go, right? There's a long tail where, those final polishing touches tend to take a bulk of the time somehow. And there are other parts of the system that we've been working on, right? So, but I mean, really in a very short amount of time with someone who's totally new to the framework, we were able to build some incredible interactive data functionality. And I just can't imagine having built this in any other toolkit. And I mean, I could be wrong. I'm sure there's some D3 wizard out there or whatever who could have done some really great work, maybe just as quickly, but this stuff is really powerful. The fact that you got all these interactivity features, which you can plug into other parts of your system, et cetera. It's all just been really well designed and really wonderful to work with. So.
Cool. Amazing stuff. Anybody have any final thoughts, questions before we go? I just had one quick question. I mean, the documentation seems pretty comprehensive, and there's lots of examples. So if somebody was just starting, I guess it's just a matter of just jumping in and trying things out and experimenting. Is there anything kind of you'd recommend to help understand the kind of wider context of like data visualization and things like that as well?
Yeah, absolutely. Excuse me. Yeah, actually for that, I'm going to share my screen again. I think one of the best ways of just getting a sense for what's possible with Vega and Vega-Lite, and I mentioned this before, but I'm glad you asked your question because it reminds me that the examples, is this right? No, examples, let's see. Oh, all right, okay, I think I know what it is. Vega-Lite examples. Yeah, cool, there we go. You can go to either vega.github.io Vega-Lite examples or vega.github.io Vega examples. And I'll duplicate this tab so you can see both of them. Yeah, so just going through the Vega-Lite examples really quick. This just, I mean, there's some silly stuff here like cows and sheep and stuff. Right. So, even with Vega-Lite, there's you really do have a lot of flexibility as far as, what you're able to do with the framework. And yeah, I mean, I think just, what's his name? His name's escaping me. Gosh, who's the data visualization guru? Tufte, yeah, Tufte, Edward Tufte, who, if you're not familiar with, he's written some great books about data visualization and really, I mean, yeah, he's a lot of his books talk about, how to sort of strip down your visualizations to just kind of the bare essentials and not be sort of sharing more than you need to. And so if you're looking for kind of a more kind of theoretical side of things, I'd really recommend Tufte as a great place to start. for thinking about, principles of data design. But one of the things that he talks about, the reason I brought him up here, is this idea of, I think he has a term for it too, but this idea of like, yeah, and to put a fine point on it, one of the things he actually recommended in one of his talks is that, if you want to learn about something, don't do a Google search, do a Google image search. Because just by scanning through a bunch of images related to whatever it is that you're looking at, you're able to kind of pick up this, the visual part of your brain is able to sort of absorb all this information at a higher level than you're able to just reading words, right? I mean, the old adage, a picture's worth 1,000 words really rings true here. And so part of why I'm, slowly scrolling through all of these examples is just that you really start to absorb this sense of like all the kind of crazy things that are possible with Vega-Lite. Even just with Vega-Lite, again, there's just a ton of great examples here. But going in real quick and kind of doing the same thing with Vega, you can see that there's definitely, you'll notice a little bit more kind of diversity in some of the things that folks have worked on, like wind vectors, volcano contours, circle packing, tree maps. I mean, there's really just word clouds. I mean, the list goes on and on, right? Actually, this list is a little shorter than the Vega-Lite one. Yeah, it's right. There's even a Monte Carlo simulation thing here, right? I mean, this is just crazy. You can go and play around with the number of points in the simulation here and see how that converges. And as you see, the Vega specifications are quite a bit longer. So that's, worth keeping in mind. But also if you're starting off with a Vega-Lite spec and compiling it, you can get a lot of that work done kind of pretty quickly for you and go in and just edit the pieces you need to. So yeah, I mean, again, to kind of get back to the original question here, the best, aside from, reading Tufte or others in the field who talk kind of about principles and ideas of data science, of data visualization, I think just, going online and looking at all the examples that are possible. Usually when I start trying to visualize something, I come through here and I kind of scan. I'm like, oh, yeah, something like this maybe looks good. Maybe I'll start with that and then, find another visualization that shows some other aspect of things that I might want to look at and then kind of thread that in. The documentation for Vega-Lite and Vega is very thorough. And really will give you most of what you need, but it's not great at kind of explaining. I don't think it's the best way to just like start at the top and read through, right? So I think, if you're interested in Vega and Vega-Lite and want to get started, my recommendation is actually just to start from the examples, because you can take something that looks like what you want and start to adapt it to something that is closer to what you actually need. And usually that involves finding one plot that's pretty close to what you want, and then another one that has some other functionality you want to add, and figuring out how to merge them. And I'll admit there is a little bit of a learning curve here, because I mean, with data specifications, you kind of have to know what the structure is, and learning some of the underlying patterns there can take a little bit of time, but it's definitely worthwhile. I mean, pretty quickly you start to see those patterns, after a few weeks or so, figure out which things can be moved where in the specification, and as that starts to settle in, you really start to appreciate the full power of the framework.
Cool, great, thank you very much. That's very useful. Thanks.
Yeah, you're welcome.
And I think we're at time. So again, thank you very much, Christopher, for this talk. It's been very great. And yeah, I hope everybody else is going to get engaged with the project and help you out with creating new issues and new pull requests as well. So again, thank you very much for your time. Thank you. Thanks.
Yeah, thank you. Thanks all for coming.
Virtual